Hello and welcome once again, ladies and gentlemen, to our virtual classroom. Today we're going to be looking at triangles. There you go. Today we're going to be looking at triangles, and so I do encourage you to take out your physical notebook and copy these notes down. As a reminder, you can also access your notes on OneNote simply by going over to the Notes tab and scrolling down to number 47. That is your newest notes in case you want to copy them all down and come back and have those ready as we go through this video. All right, so as we begin, or as we continue, we see that triangles are two-dimensional shapes. They're shapes that are made up of three angles, hence the word triangle. The prefix tri means three, like trident, tripod, tricycle. All of those mean three of something. So in this case, it's triangle, so it's three angles, right? And we know that triangles also have three sides. And so before we even talk about what those angles are, or we talk a little bit more detail on the angles, I want you to consider the following two angles. All right, let us suppose that you have an angle like this. So this is an angle. And an angle like this. So this is going to be angle 1, followed by angle, oops, that's not what I wanted. Followed by angle 2. So in looking at these two angles, we have angle 1, so it goes from here to here, and then we have angle 2 that goes from here to here. So ladies and gentlemen, if I were to ask you which of these angles is bigger, which of these is a larger angle, I hope you would say number 1. Number 1 is a much larger angle than angle 2. But Mr. Lugo, look at how long these are. Isn't angle 2 much bigger? No, ladies and gentlemen, an angle is not measured by the length of its arms. It's measured by how open those arms are. So indeed, you can see that these are way more open than these over here. It doesn't matter where you measure it. That's not where the angle is. The angle is right here. And we can see that this angle is made up of two arms that are pretty close together, whereas this other one, they are pretty far apart, no matter where you see it. So that is what an angle is. And you can actually use angles to classify a triangle. All right. So number 1, we have here what is known as an acute triangle. Well, we have acute, obtuse, and a right triangle. So notice that these are three different types of angles. We have an acute angle, an obtuse angle, and a right angle. And so when we look at an acute triangle, it is a triangle that has in which all three angles are acute. All three angles, not two of them, not one of them, but all three of these angles are acute. That means that all three of the angles are less than 90 degrees. Now, for those of you wondering what a 90-degree angle looks like, anytime you see like a rectangle or a square, anything like that. I'm sorry, give me 1 second. Then you're looking at a 90-degree angle. So this corner right here would be considered 90 degrees. This corner would be considered 90 degrees. In fact, if I make a square here, these angles here on the side, these would be considered 90-degree angles. In fact, I would do like a little square like that to show that these are 90 degrees. So an acute triangle would be a triangle, ladies and gentlemen, where none of the angles are 90 degrees. So if I can superimpose a triangle here, so let's say that I have a side that's like that, a side that's like that, and a side like that, that's like that. If you look at the angles, notice how this angle is not 90 degrees. This angle is not 90 degrees either, and neither is this one. And in fact, if you look at your textbook, you can see that they have examples here of acute triangles. Although these all look very differently, notice that none of them have an angle that is wide enough to be 90 degrees. And so that would be an acute triangle. All three of them are smaller than 90 degrees. All right, next we have an obtuse triangle. And an obtuse triangle is going to be a triangle that has exactly one obtuse angle. That means that one of the angles is going to be more than 90 degrees. In fact, in a triangle, you can only have one angle be greater than 90 and still be able to make a triangle. All right. So if this was 90 degrees, and in fact, we had 90 degrees just to show by comparison. An obtuse angle would be an angle that would actually go wider than 90. So it could be like this, or it could actually go like this. It doesn't matter, as long as that angle stretches or opens more than this right here, that would be considered. So it doesn't matter if it's from here to here or from here to here. Either way, as long as it opens more than 90 degrees, that is an obtuse angle. And an obtuse triangle will have one of those. And again, only one of those. And so we see here, ladies and gentlemen, I can see that in these examples, we have one obtuse angle right here. And we have an obtuse angle right here. We have an obtuse angle right here, and that's it. The other two are acute angles, but that's okay. Remember, an acute triangle is where all three are acute, but an obtuse triangle is where it has one obtuse angle. Now, on a similar note, ladies and gentlemen, we have a right triangle. In a right triangle, we have a triangle where there's exactly one right angle, meaning that we have one angle that is exactly 90 degrees. And the way that they will show you that in the problems that you get is that you're going to see a corner that looks a lot like the corner of a rectangle or square like this, and you will often see like a little box in that corner to show you that, hey, this is a right angle. Hey, this is a right angle. And so as soon as you see that right angle in a triangle, you know that that is a right triangle. Awesome. So besides looking at triangles based on their angles, you can also look at triangles based on their sides, and so here again, I do encourage you to pause this video and copy these down and then come back whenever you're ready to continue. But assuming you've already done that, we can classify triangles based on their sides. We can either call them scalene, isosceles, or equilateral. Scalene, isosceles, or equilateral. All right, so a scalene triangle is a triangle where the sides are all different lengths, okay? All the sides are different lengths. So you can have a triangle where maybe one of the sides is, maybe 4 inches, I don't know. The other one is 3 and the other one is 5. All right, so notice how the lengths of the sides, not the angles, we're not looking at the angles, are all different. And so, ladies and gentlemen, that would be a scalene triangle. Now, that triangle may also be a right triangle. That triangle may also be an acute triangle. That triangle may also be an obtuse triangle. But again, scalene simply means the sides are all different. Now, if the sides are all different, you can also infer that the angles are also all going to be different. So if you have a triangle where all the angles are different, like we do over here in our textbook, scrolling down, notice how here, these are all scalene triangles. Notice how all the angles are different. I can already assume that each of these sides are all going to be different lengths. So this side, and this side are all going to have different lengths. Same thing over here. Notice how all the angles are different. That means that this side, and this side are also all going to be different from one another. So in short, when I'm looking at a triangle, all the sides are different. That means that all the angles are going to be different in that triangle. If all the angles are different, all the sides are going to be different. It is a scalene triangle. Next, we have an isosceles triangle. An isosceles triangle, ladies and gentlemen, is a triangle where 2 of the sides are exactly the same length. So right here, you can see that these 2 sides are exactly the same. And sometimes they'll open wider. It doesn't have to be even up and down, but you can see that 2 of the sides will be the same length. And so it can be a right triangle, it can be an acute triangle, it can even be an obtuse triangle. But again, 2 of the sides will be exactly the same. And we know that if 2 of the sides are the same, we know that 2 of the angles are going to be the same as well. So if you do find a triangle where 2 of the angles are the same, as we do over here, notice how this one is 70 and this one is 70. I can infer that these 2 sides are the same. 2 equal angles, 2 equal sides, it's going to be an isosceles triangle. Same thing over here. If this side is 75, this angle is 75 degrees, this angle is 75 degrees. That means that these 2 sides, I may not know the measurements, but I know that these 2 sides are going to be equal lengths. Same thing over here. If this angle is 45 and this angle is 45, I can infer that these 2 sides are also going to be equivalent to each other. All right. Finally, ladies and gentlemen, we have what is known as an equilateral or equilateral. Some people might say equilateral triangle. The prefix equi means equal, lateral means side, equal side. That means that all the sides are equal. All the sides are equal, and if all the sides are equal, we can infer that all the angles are equal as well. All the angles have to be equal as well. So coming over here, notice these equilateral triangles. So if they're equilateral, that means that all of these sides are going to be exactly the same length. So this side, and this side. I may not know the measurements, but I know that they're exactly the same. How do I know that? Well, because they're telling me that these angles are the same. So if they are equal angles, I know all the sides are equal also. Notice that it's the same for all of these. Now, not only are all the angles the same inside an equilateral triangle, but notice how the measurement of that angle, it's always 60 degrees. So if it's an equilateral triangle, even if it's a larger or a smaller one, the angles will always be 60 degrees. That's how open the angles are going to be. So please write that down. An equilateral triangle can also be called an equiangular or equiangular triangle, which means that all the angles are the same. And again, the angles will all measure 60 degrees in an equilateral triangle. Finally, ladies and gentlemen, and this is super important, please underline this, highlight this, circle this, whatever. But just know that if I add up, or the sum of the angles inside a triangle is always going to be, the sum is always going to be 180 degrees. It doesn't matter what the triangle looks like. It doesn't matter if it's scalene, isosceles, or equilateral. It doesn't matter if it's a right triangle, an obtuse triangle, or an acute triangle. The measurement of the angles inside will always be 180 degrees. In fact, it is impossible to draw a triangle or to have a triangle where the angles, the interior angles do not measure 180 degrees. So if you were to look at these triangles, notice how in all of them they give you the angle measurements. If you were to add all those up, and these are accurate, these are to scale, they're always going to give you 180 degrees. For example, 30 plus 135 is 165, plus 15 is 180. All right. 40 plus 20, that is 60, plus 120, again, is 180. 90 plus 70 is 160, plus 20 is 180. 40 plus 85 is 125, plus 55 is 180. So no matter what, 60 plus 60 is 120, plus 60 is 180. Ladies and gentlemen, it is always going to be 180 degrees, 180 degrees. And that's just something that's important to know. That will be, I promise you, it will be relevant in a test or Kahoot or anything really. All right. So having said that, let's go ahead and mark the numbers that you are responsible for. So ladies and gentlemen, you are going to be doing number 3, and you're just going to be doing A. Don't worry about B or C. You are going to be doing number 4, which is A and B. You are going to be doing number 6, which is A through E, number 7, and number 8. And as a bonus, I have included numbers 20, and 21. Those are optional for extra practice if you want them. All right, so going over to number 3, what we have to do number 3 is that we're going to label these triangles up here. We're going to label these triangles up here, all 9 of those, by their sides. Now, if we look at our notes, if we're labeling by the side, that means that we're going to label them either as scalene, isosceles, or equilateral. Those are side labels. Acute, obtuse, and right are angle labels. By sides is scalene, isosceles, or equiangular, or equilateral. Sorry. So that means that each of these triangles, I'm going to label as either, if I'm going by the sides, as scalene. I'm going to label it as scalene isosceles, or as equilateral. All right, so let's look at, so again, this is number 3, and I'm going to look at triangle A first. So look at triangle A right here. Notice how all 3 of these sides are exactly the same. Even though it's an acute triangle, it's an acute equilateral triangle. Because all the sides are the same. For B, notice how none of the sides seem to be the same. They all seem to differ. So it's an acute, but I would call it a scalene triangle. an acute scalene triangle. Scalene because none of the sides are the same, even though all of the angles are acute angles. And here we have another acute triangle. However, this one you can see that these two sides are the same. So this would be an isosceles triangle. So it's an acute isosceles triangle. So I've done A, B, and C. Now, ladies and gentlemen, you make sure that you do the same thing for D, E, and F. For each one of those, you're going to mark, is this isosceles? Is it scalene? Is it equilateral? And you're going to do the same thing for G, H, and I. And you will do that on your own. You're going to mark, for example, looking at D here, these two sides seem to be the same. So that seems to be an isosceles triangle. Isosceles triangle. And on Schoology, you'll be able to click on a word bank to verify, so you don't have to worry about spelling. All right, so that's for number 3. Number 4 is super simple. If you simply paid attention to the notes, you can get this just by reading the question. Find the sum of the angle measurements for each triangle. If we go to our notes, remember, the sum of all the angles in a triangle will always be 180. It will always be 180 degrees. And as we proved earlier, when I took the sum of each, 135 plus 30 is 165 plus 15. It is always going to give you 180 degrees. It doesn't matter. As long as it's a triangle, it's always going to be 180. And that's what it's true in real life. It's true in the problems. It is always going to be 180. What is the sum of the angle measurements? Again, it's 180 degrees. So that's super simple. I basically just gave you number 4. All right, moving on to number 6. Number 6 is one of those that's going to take a little bit longer. But notice how they give you 2 of the angles. We have 43, 94, and we're missing an angle. Now, I may not know what that angle is, but I know that if I were to add all of these angles, ladies and gentlemen, the measure is going to equal to 180. It's going to equal to 180. So again, if I have, so this is number 6A. So how would I figure this out? Well, basically 43 plus 94, that's going to be, so let's go add that together. So 43 plus 94, 4 plus 3 is 7, 9 plus 4 is 13. So I know that these two together are 137, but I'm missing a part to get to 180. It's almost as if I'm saying that 137 plus something else, can you put a variable there, plus X is equal to 180. All right. Well, if 137 plus something is 180, then 180 minus 137 will give me that something. So let's do 180 minus 137. And when I subtract that, I see that that gives me 43. That means that my missing angle is 43. And that is the answer to number 6A, 43. 43 plus 94 plus 43 is equal to 180. That's the only angle that it could be. All right, let's try the next one. So again, we have 38 and 52, and we're plus an additional angle together. That should give me 180. Well, 38 plus 52, I know that that is 90. So 90 plus something is going to give me 180. So let me subtract them. 180 minus 90, that again gives me 90. That means that my missing angle here is 90 degrees. 90 degrees, right? 90 degrees. So 38, 52, 90, those are the angle measurements for this triangle. Now, so that's number 6. You're going to do the same thing for C, D, and E. But with that in mind, let's go to number 8, because number 8 tells us to go back to number 6. Go back to number 6. We're going to classify each of those triangles by the sides and by the angles. So that means that for each of these, basically this is going to be 8A, and this is going to be 8B. We're going to do that for each one, 8C, 8D, and 8E. For each one of these, we're going to have to classify them by the side and by the angle. By the side and by the angle. What do I mean by side? Well, by side, it's either going to be scalene, isosceles, or equilateral. By the angle, it's either going to be acute, obtuse, or right. So let's go and look at the side. So obviously, I don't know what the side measurements are, but I do know this. I see a pattern here. I see that There's a 43 and a 43. So two of the angles are the same. That means that two of the sides are going to be the same. And I know that whenever I look at two equal sides, that's going to make this an isosceles triangle. Now let's look at the angles. The angles. So I have an acute angle. I have another acute angle. But look at how I have an obtuse angle right here smack in the middle. I have an obtuse angle. So remember that if you have an obtuse angle in a triangle, automatically, ladies and gentlemen, that makes it an obtuse triangle. Obtuse triangle. If we do the same thing for 6b, with that, which that's going to be 8b, notice how there is no repeating angles. All of them are different. That means that all the sides are going to be different, just like we saw over here. If all sides are different, all angles are different, that's going to be a scalene triangle. And when I look at the angles, notice how we have an acute angle, and we have a right angle. So as soon as I see the right angle, I know, ladies and gentlemen, that's going to be a right triangle. So really, for 6a, I have an isosceles obtuse triangle, or I can say an obtuse isosceles triangle. For 6b, for 8b, sorry, I have a scalene right triangle, or a right scalene triangle. I'm saying a triangle with 3 different sized sides, and it has a right angle. That is what I'm saying here. So yes, we're doing 8 and 6 at the same time, 6 and 8 at the same time. And on Schoology, the way that this looks, if I can just quickly open up Schoology. Just to show you what the submission is going to be looking like. We go into today's folder on Tuesday. And if I preview the attempt, you can see, ladies and gentlemen, that for this is number 3, number 4, number 6. For number 6, you're just going to put the degree that is missing. But for number 8, again, you have two blanks for number 8A. So we said that the side for number 8, that's not number 8, that for number 8, we have an isosceles obtuse triangle. So for number 8, sorry about that, we're going to put an isosceles, because that's the side. Isosceles refers to the side angle. It's either going to be acute, obtuse, or right. Isosceles, and we said that it was an obtuse, I believe. Obtuse, isosceles obtuse. Let me check. Yes, we have an isosceles obtuse. For 8b, we have a scalene, because all of them are different, right triangle. So guess what? For the side, it's going to be scalene, because all the sides are different. For the angle, we have a right angle, so that's going to be a scalene right triangle. All right, you're going to do that all the way down, ladies and gentlemen. And so give me 1 second, ladies and gentlemen. Yes, Mr. Bigelow. I think he is. All right, sorry for that interruption. Let's continue then. So finally, let's look at number 7. Number 7. All right. And that's super easy. A triangle with 3 different angle measurements. Okay, 3 different angles, so 3 different sides. So that's going to be, these are going to be scalene, isosceles, or equilateral. You tell me. A triangle with exactly 2 congruent angle measurements. So 2 angles, congruent means that they're the same. So 2 angles that are congruent. So 2 sides are going to be congruent. What is that going to be? Isosceles, equilateral, or scalene. And finally, an equiangular triangle. All the angles are the same. That means all the sides are the same. What is that going to be? You can do that on your own, ladies and gentlemen. All right, I hope you found this helpful, ladies and gentlemen. If you do have any more questions, feel free to email me, and I will do my best to get back to you in a timely manner. But with that in mind, I will see you. I'll see you soon. I will see you soon. And again, I hope you found this helpful. And yeah, please do not hesitate to reach out to me.